So we're integrating piecewise functions here today and absolute value functions, which are really just piecewise functions. So that's our goal here. Go ahead and copy down example 1. You don't need to draw the picture, but you can if you're quick about it. Okay, so when you're integrating piecewise functions, you have to break it up in pieces. Okay, so now you're not going to have a picture on your homeworks that you're going to be working on. You're just going to have the equation, but I include the picture just so you guys can understand the concept of why we're doing what we're doing with the equation. So here's my piecewise function. The function is 5 for all values of x less than 3, so that's why we have a straight line there until we get to x equals 3, right? And then 2x minus 1, that's this line, is what we get for all x greater than 3. And the reason why I stop at the endpoints here of x equals 1 and 5 is because I'm asking you guys to find the integral of this function only from 1 to 5. Piecewise functions have to be treated as pieces in calculus. You have to deal with each piece separately. So this means area under the curve. Now we could do this geometrically. I could find the area under this curve. I could turn this into a rectangle and I could turn this into a trapezoid and get my answer, right? But like I said, you're not going to have the picture. You're going to have the equation. So that's just for show there to help us understand what we're doing. So the deal is, since we're dealing with a piecewise function, when you take the integral, what you have to do is you have to break it up into pieces. Yeah. So the first piece, well, it's going to start where the integral starts. It starts at 1. But it's not going to go all the way to 5, right? Because after that, somewhere in the middle, it switches pieces, right? And where does it switch pieces at? At 3. So that's how you know where it switches, where that little inequality is at. So the first piece is only going to go from 1 to 3. The next piece is going to go from what to what? 3 to 5. Okay? It could have 2 pieces. It could have 3 pieces. It could have 4. I've never seen them do anything more than just 2, but, it can happen, technically, right? So, now here's the thing, though. For the piece that goes from 1 to 3, which piece is that? Is it the 5 or is it the 2x minus 1? Now here's why it's the 5. If you didn't get that right, here's why. Look at your limits. I'm going from what to what here? 1 to 3. And both of those numbers are less than 3. Well, 3 is not, but you get me. The interval from 1 to 3 is less than 3, right? So since this interval is less than 3, it's the top piece. So we're going to put a 5 there, okay? And the other one here from 3 to 5, that's for stuff greater than 3, right? So that's going to be 2x minus 1. Now we are going to do some of this today by hand. I'm going to skip this because I did it with my last block, and what I found is that people are forgetting how to integrate, which concerns me because I've been giving you guys integration review every week. I'll slap you. Don't be ungrateful, okay? And the other issue with these, there's tons of little places to make little math errors, tons of them. So even I will, not that I'm like all that great or anything, but like, I've got a lot of practice, right? I make mistakes constantly as I do this stuff. So there's just so many places to make errors. So actually what I'm going to do is I'm going to do things a little differently than you with my first block. I'm not going to actually have you guys work this out right now because I just want to make sure you know how to set it up. We will do one together in class today, and it'll be a nightmare. I'm going to pick a hard one. But after that, I'll let you do it. Because this is really what matters to me, is this. Can you split it up appropriately? So let's go ahead and have you guys try one really quick. You don't have to copy the whole slide, okay? Just have your answer ready for me, and I'll call on you in a second. Go. So Brody, where do we start at? What's the first limit down here?
-2.
That's good.
To 1.
Good, yes. And then next one, I'm going to go to Chris. So this one goes from -2 to 1, right? And then Chris, Christopher Ignacio, where does this one start at? Okay. And then I'm going to ask, Ryan's not with us. Ashley's not with us. Sam, where do we end at? 3, good. And for the interval, the first interval, it goes from -2 to 1. Serena, what function am I going to put here? Okay. Thank you. And then the last one will be the other one, right? 3x squared. You can put your dx there. And there you go. So if you got that far, I'm happy. We are going to practice integrating some of these in a minute, but for now, I just want to make sure you know how to set it up. Okay. All right. Let's do some absolute value stuff here. Absolute value functions are really just piecewise functions, right? They're just really two functions being put together at a cusp. So go ahead and copy down guided practice number 1 here real quick. You don't really need the picture. Once again, that's just a visual aid. We're not going to really use it for much, other than just kind of understanding what we're looking at. So since we like to think of absolute value functions as piecewise functions in the class, we need to turn it into a piecewise function. So you could tell from the graph, where do we switch from one piece to another? At -3. But once again, we're not going to have the picture, right? So how do we get that -3? Sorry, I'm going the wrong way here. I hate this board. All right, so how do we find that place x equals -3? Good, you set that piece equals 0, right? So how do we find the cusp, right? How do we find the cusp? All right, so you set the 2x plus 6 equal to 0. And so we end up with x equals -3, right? And then what I told you guys to do after that is we want to put this into a piecewise function, right? And half of the equation is going to be for everything to the left of -3, and the other half is going to be for everything to the right of -3. You have to make one of them equal, though. Okay. Now, what we talked about was what happens is you're going to write this same equation twice, but one of them's going to change the signs, right? And how do you know which one changed the signs? Well, we test it with a number line test here. So, for instance, let's pick a number that's less than -3. -4. Sure. So if I do this, I get -8 plus 6 is -2. Will the absolute value signs change that outcome? It will, right? So this one will change the sign, right? And the other side will be not changing. So I'll just put in C for no change on this side. It's always opposite. So once you find one, it just kind of flips back and forth after that. So what that means is for anything that is to the left of -3, we're going to change the signs of our equation. Okay? So this is left of -3. So that means whenever I put my equation up here, the 2x plus 6, it's going to become -2x minus 6. Okay? But for the one that's to the right of 3, we don't change the signs. So we haven't even started answering the question yet per se, because the question's really asking us to integrate that function, right? But what did I have to do first? First, I had to change it to a piecewise function. Now that it's a piecewise function, it's exactly like the last problem we did. So where am I going to start at? -5. And it's going to keep going until we get to what? Then we stop at -3 because that's where the pieces switch, right? And then after that, it picks up at -3 and ends at 0. And which of these pieces goes from -5 to -3? Yep, the negative one, right? And then the positive one goes here. There you go. So that's the only difference there, is that you have to change it into a piecewise function yourself first, okay? Once again, I'm not going to evaluate it yet. I'm just going to leave that and say, okay, we're going to stop there. We will do one, not yet. I want to save a really nasty one for you guys. That'll be the next one. We'll do the next one. Okay. So, can I clear it? Thank you. All right, so go ahead and write down guided practice 2. This time I'm going to let you guys do most of the footwork until we get to the, well, I'm going to let you guys actually do most of the footwork here. I'm going to be calling on you guys a lot, so be ready. Be listo.
Have you ever seen that video of that guy with glasses and he kicks the camera out with his hands?
You know, I'll probably do that someday and get fired, but
She's a terrible girl.
just know that it wasn't on purpose. Okay, so I'm going to call on you. Ready? The first thing I need to do is I need to change this to a piecewise function, right? So I'm going to ask Dario, what's the first step if I want to change this into a piecewise function? That's right. Now, the next person I call on is going to be required to think a little bit more because it's a little different. We got our max. What would I do to solve this? Okay, so what would we do to solve this?
Oh, we factor into it.
Oh, you already factored it. Good. All right, so you already factored, but you're going to need to factor. And that would be x plus 2, x plus 4. Okay. Jennifer, what's next?
You said each of those so x plus 2
Good. And each of those things tells me what, you guys? Where those cusps are. In other words, it's the breaking point for where we switch from one piece to another. So if I've got 2 cusps, how many pieces does this function have? It'll have 3 pieces. Okay? So this one you're going to need to think about a little bit. We're going to have 3 blanks here, but I'm not worried about these ones yet. What I want you guys to do is I want you to do these 3 blanks over here on the right side first. Okay? See if you can set it up, and I'll call on you in a second, but take a minute. Nate, what do I do now? It's kind of an open-ended question, but what do I do now?
Okay. You do that thing.
The number line test kind of thing to figure out which one changes signs, right? So you have 3 intervals to test, right? So hard time here. All right, so we have -4 and -2. I'm going to have you guys go into your number line test here, and you guys are going to see which of these pieces change. Go ahead. I'm going to do the middle here because it's easier, but if you pick a number, actually, you know what? I'm going to pick a number over here. I think over here would be easier. So let's say I pick over here, right? Plug in 0. If you plug in 0, what are you going to end up with? Absolute value of 8, which does that change? So no change, change, no change. So it's the middle one that changes, and the 2 on the ends don't, okay? So there's that. Now I want you guys to do the next part, because I want you guys to set up your integral. So I'm going to ask you to set up your integral. How many integrals am I going to have?
3.
Integrals are
-5 to -4, -4 to -2, and -2 to 0.
good. And what did you put here, Austin, for this one?
X squared plus 6x plus 8 dx.
And this one?
Negative x squared minus 6x minus 8 dx.
Good. And you don't have to tell me the next one because I know you know that then. Okay, so here's what your,
Oh no.
yeah. Math teacher snaps in the middle of class and breaks whiteboard to the students' dismay. It's coming. All right. I hope not. That'd be sad. All right. So there's your guys set. Now we're actually going to do some integration. It's going to make you sad. All right. So I want you guys to begin doing this. Now we're not going to use properties or any of that stuff. We're just going to integrate old school style. Yeah. So we start at -5, right? And we go. We stop when we get to -4. And then from -4, we go until we get to -2. And then after we get to -2, we move on to our last point, which is 0. Does that kind of make sense? All right. So I want to, I have a picture which I could show you too of this thing that'll help, but the graph looks, well, I'll show you later. But for now, let's go ahead and do our integration. So I want you guys to integrate just this first one for me. Go ahead and integrate just the first one for me. Just the first one. Go ahead. Marcos, what did you get?
So I got x cubed over 3 plus 3x squared plus x.
Yep. So the power rule is you add 1 to the power and divide by that number. So if you add 1 to 2, you get 3. If you divide by that, you get x cubed over 3. Add 1 to your power, you get 2. Divide by 2, you get 3. And so now when it's just a number, you just put an x next to it. So that, now all the other ones, good news, all the other ones are exactly the same. So we don't have to do that math again. But for this middle, you don't put that anymore, right? We do brackets. So the other ones are the same, it's just that they're going to be negatives, right? So let's go ahead and do that now. Oh, poop. Okay, let's see. -4 to -2. Oh. Yay. Yes. No, it's beautiful. All right. So I'm going to show you guys I'm going to help you out here a little bit. So what you have to do is you have to plug in 4, right? -4. And then you plug in 5 and you subtract those two things from each other. Okay? There's a lot here, and there's tons of room for mistakes.
Wait, so on the FRQ though, would we just leave it like this?
You could leave it where they're plugged in, but so the reason why I was really just focusing on the setup is because that's all that you kind of need. I've never seen them do this because this takes too long. You know, you only have about 3 minutes per question. But this is a good skill because you do have to do this to some extent on the test, but with smaller versions. So I'm just letting you guys practice with a really nightmarish one. All right, so here we go. Here's how we're going to set this up, you guys. We're going to follow my lead here. To be successful with these problems, organization is key.
Yes.
You have to be very organized. If you're disorganized, you're probably going to make a mistake somewhere. So you want to be as organized as possible. So this little setup that I'm doing here, this is what I would advise for you guys, to set it up like that before you even begin. For every integral, you're going to have a set of brackets, and inside of each set of brackets, you're going to have 2 parenthesis sets with a minus between them, right? So for the first one, we were plugging in -4, right? So if I were to plug in -4 to x cubed over 3 plus 3x squared plus 8x, let's see what I would get. All right, so it's going to be what? What is -4 to the 3rd power? -64, right? And what if you plug it into 3x squared?
48.
48, good. And what if you plug in -4 into the last one? -32. Okay, let's do the next one. We're plugging in, oh wait, that was 4 though, huh?
Yeah.
Okay,
Wait.
that is right. Okay, now we plug in 5 next, right? The -5. So what's the -5? What's -5 to the third power?
Oh my god.
125? Negative 125.
And the next one, if I plug it into 3x squared, and if I plug it into the last one, okay. Why don't you guys do the other 2 sets there, and I'll call on you in a second here. It's there, but my calculator's kind of goofy right now, but there's a 0 here. So now we're going to go ahead and put in dx here and push enter. And these, oh, thought I did it right.
Is it a 0?
It might be. I thought it just had a typing issue. Done here. All right, well, anyway, you go ahead and type it in, push enter. A lot of times this makes your calculator think a whole lot. They have a really hard time computing these, but there's the answer. Now, if you were to convert that into a fraction, I believe it comes out to be, I wrote it down earlier, 28 over 3. 28 over 3. So if you did it by hand, you should have gotten 28 over 3. Okay?
No.
So, sorry guys, I know it's tough stuff, but so on your homework, mainly what I'm concerned about is the setup, but I do want you guys to try to calculate the integrals by hand. Okay, do the best you can, but we're mainly looking at the setup. Okay.